All right, what's up, everyone? Welcome to week 82 of building my own operating system, formerly known as chill kernel hacking for fun. Let's get into it. Okay, so today we're working with C++ standard libraries. That's kind of the focus here today. In particular, interested in freestanding and embedded C++ standard libraries. There's a couple interesting ones out there that I've flagged that I think I want to look at. So there's the Frig project, there's ETL embedded template library, and then the freestanding C XX headers. Yeah. So freestanding CXX headers isn't exactly like a full. I mean, none of these is really a full STL. It's kind of unclear what even a full STL would really mean for this case, but they each have different things that I think would be pretty useful, because I don't really want to write a lot of my base data structures from scratch. So it seems like these projects have some pretty high quality implementations. So I think I would like to use some of these. Freestanding CXX headers is literally just the lib C++ or libstud C++ headers that have been extracted and packaged into a way that they're usable, more easily usable. So yeah, I'm just gonna launch a quick test 0 in the chat as usual. And it looks like everything is working. Hey Mohammed, what's up? We're live on Twitch right now, live on YouTube. Everything's set up. All right, cool. Well, yeah, welcome to everyone joining the. Hey Varun, I'm gonna learn Flask, man. That's cool. All right, so basically just to kind of recap, last week we were working on these two things using LLDB and porting basic C++ support to the CMake branch. And that's what we're seeing here. Basically I've just got these two branches that were merged. Hey, Surveillance Van, what's up? Hey Mohammed, yeah, first time on the channel. Well, I mean, welcome. Yeah, I mean, if you want like a bit of a longer recap, feel free to go to my welcome page. Here you can read that. It's not too long, but basically, I mean, yeah, I'm streaming OS development. For a long time I was streaming myself doing the labs for this MIT course. I eventually finished that course, and then I've been kind of doing my own thing and slowly working towards making my own operating system, which I don't know, I just want it to be a clean, minimal operating system that I can use for learning, but also maybe doing some experiments. Yeah, that's kind of the concept. Thanks, Varun. Appreciate that. Okay, maybe let's do a quick demo of what happened last time, hopefully. No, I don't really plan to make it a lot like Linux. I'm planning to, like, I think there are way too many POSIX-like or Linux-like hobby operating systems out there, and so I'm not so interested in making just another clone of that, and I think I'd rather pursue some other ideas in the space. So we have our QEMU debug target, and then we can do LDB, and then that should put us into an LLDB prompt, and then we can start debugging. So that's what we were working on last week. So now we're in a debug session. So that's cool. It's nice to be using LLDB. And then we could also just see, incidentally, a bit of the C++ demo work that I was doing last time, where we have this like test C++ file in the kernel, and it's called, basically it exposes this function called loop that can be called by the C code. And this function, the loop is not a good name, but in this file we can use C++ features, and this is just a little bit of a demo of showing some of that working. And the key demo that we got working is virtual functions, where we can have a parent class, and then we can override some methods in child classes, and then write a function that does virtual calls and takes the interface. So that was a pretty big win. I consider that a pretty useful feature and a pretty important one. So it's nice to get that working. Yes, so that was all last week. So now we can kind of pick up where we left off. And my idea is to look into some of these C++ STL libraries. In the future, some data structures probably are nice. I mean, these include some data structures also, but some of them might require allocator support, which we don't really have. Some sneak peeks for the future are just more base project infrastructure. That's kind of the emphasis of this whole kind of current phase of work, is just getting a nice solid base project infrastructure going. And then once we have that, we can actually start writing the kernel. But I consider this a prerequisite, because in order to do programming, you just need to have some tools available for you to do your work. And if you don't make those up front, you can just try to jump into the actual writing of the code, but you're going to immediately run into not having the tools you need. And so my idea is just to kind of spend some time getting this all working in the first place. So that's the idea. Let's check the notes from last week in case there's anything I forgot, but that was pretty much the idea from last time. So let's just do it. I think this should be pretty exciting today. I'm pretty excited. So like I said, there were a couple main options: Frig, freestanding, CXX headers, and ETL. Let's just take a quick look at what these projects are. Frig, GitHub. So here's Frig. ETL is this one. And I am just curious to explore both of these projects. Even if we don't end up using them, I'm still interested just to learn about them and see how difficult it is to port them also, or to even just include them in the build. I don't know. And then there's freestanding. Freestanding. Oh, why are these archived? That's new. Hey Bacon, good morning. What's up? How are you doing? Nice to see you again. Yeah, thanks for joining again. Why are all these archived? That's super new. I wonder what happened here. I wonder if things got moved over here. Maybe. Updated 5 days ago. I wonder if they moved everything over to GitHub now. That's interesting. Anyway, these are the main things I'm interested in checking out today. So I believe actually Frig is not completely standalone. If we look at the Frig code, we can pretty immediately see that it requires some standard library headers, actually. So it's not totally correct to say that it's a fully standalone library. And that's where the freestanding CXX headers would come in, because these provide those headers that we need. There's also one other project that I want to point out, bare flank BSL. So this is just another project I came across when I was doing some research into this thing. It seems like a pretty interesting project. It is, I don't know, it's like this header only standard library sort of looking thing, but it's used by this hypervisor project, which is in this organization, but they separated out the standard library, and it seems to have some useful utilities, but I'm not sure if it's redundant if we're also using freestanding CXX headers. So yeah, what's up, Cher? College final year project ideas. I'm sure there's some good ideas in here. Yeah. Cool. Yeah, let's get started. How should we start? Probably, I think starting with the freestanding CXX headers is a reasonable place to begin with this, because I have a pretty strong belief that Frig will need it. So let's just try to add it. So I have my third-party directory, and I'm going to make freestanding CXX headers. And I'm going to go in here and actually, what's the structure that we're using? So make dir. So I'm going to do git clone. I guess the master branch. I don't suppose there are any releases, so YOLO, I'm going to use the master branch. I'm going to do a shallow clone, and I'm going to move this. I'm going to call this upstream. What's up, Akshay? Why are you doing this? Just use Temple OS. Nice. Can you get Temple OS building? I don't even know. I thought it was kind of this unique, I don't know, project. I didn't know if you could do that. That would be a challenge. All right, so we got the project here, and yeah. You're too nice, Bacon. You're way too nice. Okay, so let me think. What is? How do I do this usually? So go. Yeah, I mean that's the dream, to go full Terry Davis. To be honest, that's really the real role model here. So apparently the way I was doing it is I was adding this commit file, sort of a dumb way of doing it, but whatever. I'm just gonna roll with it. You might say, why don't you just use a submodule? And I don't really have a great reason yet, other than I just sort of don't love submodules, and I'm trying to avoid it if I can. Right. So we're at commit, blah, blah, blah. Cool. That looks right. So now I'm going to go into here and I'm just going to delete the git directory and just check one more time that I got that commit hash right. Yeah, it looks right. Okay. So now time to freestand cmake lists, copy path. So now time to make lists. So now time to basically copy this and I don't know. How do you like what? Yeah, what? I686, and then it's what is this? I686 include. I think we need the same thing. It's just upstream I686 slash include. Okay. And then this will, then we have all our headers. And if this really works, then that should basically be it. I'm most excited to have Stood Atomic available. Anyway, so theoretically, this is actually it. So we're just going to make a commit that adds so that x freestand cxx headers and add freestand. Oh wow, dang. Stand cxx headers. Okay. All right. Cheers, Varun. Thank you for joining. Appreciate it. Have a nice rest of your day. Cool. So, so how do we test this, for example? Let's say I wanted to test using one of these new headers. And let's say I want to just write some code in this test.cpp that used it. How do I do that? So probably I need to go to the kernel binary and add the dependency. Extend. Freestand cxx headers. So basically what I've just done is I put in the library into the project, and then I added this file which integrates it into the build system. And then once it's in the build system, other parts of the build system can become aware of it and even depend on it and use it if they want. And so I just added a dependency from the kernel is going to depend on those headers now and should be able to use them. Hey, me here. Consistency is another one. Thank you, man. Appreciate that. Yeah, just once a week. Once a week. It's once a week for 2 hours is not the heaviest lift for me, and so it's not so hard to maintain the consistency. And I just enjoy this a lot. It's just super fun. Okay, so we've declared the dependency, and I'm just going to rebuild it. I don't expect that anything is really, interesting. Unable to find, oh, that's, okay. How did CC runtime do this? CC runtime private freestanding the headers. And I could have sworn that I did it the exact same way. So what file? We're looking at the C headers, and then I'll open the CXX. I mean, that really looks super identical to me. Do I need to reconfigure? This is interesting. Why would the CC runtime? CC runtime is this actual library, and it target links library private blah. Target link library private blah. I am not seeing why, like, what's the difference here? I was able to successfully depend on X freestanding C headers, which is this ultra simple library here, and I do the exact same thing, and then it seems to be not working. And the problem is with linking. For some reason, it's acting like there's an actual library to link. What's going on there? What I want to do is see runtime. What happens if I build CC runtime? Here's the okay, this just builds a static library, so there's no linking involved. Bit puzzling. What do I do about this? This is a problem I really don't care that much about solving. So let's try using codecs. Let's try. Yo, what's up, Ismail? Nice to have you. Welcome back. Yeah. I'm getting this error. So today I'm trying out using OpenAI codecs instead of Claude Code, although we do have Claude Code right over here if we need to use it. Overall, the experience wasn't that great with the codecs. Can you find out why? Please read the CMake list of text files to understand the build system. I'm confused because I thought I declared X blah, 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 as an interface header only library. Yeah, I'm pretty new to it also, but it's just the alternative to Claude Code. Oh, true. Oh, wait, I think that's actually the problem. Yeah, no, I forgot to do an add. I potentially forgot to do an add subdirect. There we go. That's it. Okay. Oh, that's interesting, actually. So I forgot to do this add. So I don't need this. I think I don't need this help anymore. I forgot to do the add subdirectory, which means CMake wasn't aware of this file in the build. And actually, if you don't, if that happens, apparently it's not an error when it runs into this thing and doesn't know about the target. Apparently it just blindly injects the -L, this thing, which I don't know if I love that. Maybe it makes it a bit easier to use system libraries. All right, so that was actually kind of cool. So I mean, it didn't. Okay, check it out. So so we have freestanding CXX headers nominally available, and now let's try to use it. And so now we just need to find a good header. So like, what's a good header? Anyone have a favorite header? Let's try. I don't know. I mean, I think the atomic is probably one of my favorite headers. So if I do atomic, I wonder. It looks super weird to just have it with these quotes and then no file extension. Like, it would look more normal to have it like this, but I don't know if I have the brackets. I don't know if that's like set up yet. So I'm just going to just try this. And the question is, like, does this work? Check it out. It didn't work because studint.h is not found. And studint.h is not in the CXX headers, but I think it is in the C headers. So it's a good thing we already have the C headers here. So let's just do a check. Studint.h is here. So I think what that means is I need to rely on both. So we're gonna have the kernel is going to officially, okay, this might be problematic actually. We're gonna officially depend on the C headers also. Yeah, oh, what's up, John? Bracket included angle are more or less stylistic, by the way. I thought there were like some compiler somehow. I thought that somehow it affected the search order or something, but true. I think it. Yeah, I think you're right. So I'm going to depend on the C headers, which might solve like this problem, but it might create other problems because I don't know, there might be conflicting I don't know, there might be conflicts of some kind because the kernel already has its own notion of some of these std C headers, like not this one, but I mean, types.h is not a standard header, but I don't know, std.io, for example, like there's like an assert.h. I think that is literally a header in the, nope, apparently not. All right, you know, whatever. Let's just just keep going. Okay. Oh, interesting. Interesting. All I'm trying to do is use some of these supposedly freestanding headers. Too many arguments. And it's like tripping up internally. Like all I did was include the header, and internally template class, I think the problem is static assert. Yeah. Yeah, no, the problem is static assert. And this is exactly what I was talking about. There's like these, well, actually, I mean, kind of not really, but JAWS includes its own static assert. And that is conflicting with C++'s static assert keyword. And causing some problems. Interesting. What is... There's basically two ways I can go with this. And the first way I can go with this is to kind of keep just pushing, like basically keep trying to do this all within JAWS. This is an example of a problem that I'm only running into because I'm doing this within JAWS, and we have this like weird legacy code with like the legacy code base, and we're trying to add like new C++ support on top of it. And what that means is this problem is like kind of artificial and not fundamental to what we're trying to do. And the other alternative, which is kind of tempting, is to actually just get rid of JAWS and like just delete like all the C files basically, which would also kind of solve this problem. And I'm actually super tempted to do that. Yeah, because I think, yeah, JAWS is kind of getting in our way more and more these days, but I think what I will do, if we hit a lot more of these problems, I'll do it. But for the moment, I'm just going to do like a big ass rename, I think. And I'll call this C assert hack maybe. And I think this will solve that immediate problem. Yeah, F it. Okay. So we're going to rename this static assert hack. And it should no longer conflict. Check that out. That's pretty cool. So rename static assert. It was the legacy C static assert. Yeah, JAWS time is over. Yeah, sorry, have to fire JAWS. It was super useful all this time, but time to graduate. Not right in this moment, but soon. Definitely coming up. Conflicting with C++ static assert. All right, so now we're at least building, and so now the final thing we need to do is just test if this works. And we are getting a squiggly line here because it, I don't know, something cannot find and include or whatever. Let's just go here and let's try to use an atomic stood atomic int, and I don't know, let's just atomic int equals 2. Moment of truth, does this work? It's gonna, I don't know. Wait, yeah, okay, how, atomic int, I don't even know how to print, how do you print an atomic? Atomic int, like I don't, this is not something I've run into before because I'm never print effing atomics because I'm always using C++. Can you, do I need to cast it maybe? Store, I guess, wait, I guess load. All right, load. So we should see atomic int 2, I'm thinking. That's sort of the idea. Atomic int 2, check that out. That's pretty sweet. All right, so it looks like we sort of have the CXX headers working, which is really exciting. And I'm gonna take a 20-second break. Be right back. All right. So I mean, yeah, I don't have any like current uses of atomic planned or something, but it's just nice to have this as part of just the base infrastructure for the project. So I'm realizing I actually kind of messed up and I accidentally included this does not go on this commit, and this does not go on this commit. So let's get those out of there. All right, this all goes. So for this, first of all, this goes into here, and then this. Shit, I did it again. Wait, this does not go in here. This needs to go out. All right, this, and then this gets fixed up into there. So we have our commit, which adds the include, and actually, yeah, let's test out some of these brackets. How about those brackets? Does that work? Seems to work. It built, and ran. So let's, I don't know, yeah, maybe let's use these. So all right, anyone else have any favorite headers? Like, I mean, wait, these are the C headers. I mean, there's a lot of good ones. Stood array. Dang, did not mean to open that in text edit. Okay, like, I don't know, can we use an array? My array. Size, my array. Size, for example. Yeah, I'll be pretty excited to use some stood arrays. That would be pretty cool. Oh shit, what am I doing? Int 16, there we go. Check that out. So, and I don't know, like I want to test out move, if stood move works. Stood, so we don't actually have that many optional though. I mean, this is the real deal. Can we have an optional int? And then we're gonna do like my int has value, right? And then we do my int has value, and then we're gonna do like why don't I have completion for 2? And then we're gonna print that out again, and we're just gonna print the value. Okay. This is really just kind of playing around. That did not work. Why didn't that work? Oh. Did I typo it? I wrote oh my instead of oh my int. No, I think this is different. Like what? Okay, something's messed up. Oh wait, I didn't include it, that's why. Dang, okay. Okay, has value 0, has value 1, 42. That's sweet. Optionals are working. So that feels nice. Ismail, you asked about smart pointers. There are no smart pointers provided. Oh, wait, are there? Am I wrong? I don't see smart pointers. Or wait, no, wait. They would be in, actually, wait, maybe. Wait, unique. Actually, yes. Also, what standard am I using? Where would I even find that out? C++ 20. Can we just like bump this up to 23? Does that do? Wait, I'm not gonna do that right now. I'm just in the middle of something else. So, bits unique pointer. So actually, yes, it does look like we have smart pointers. I'm a little bit less sure about using them, just because that's kind of where I mean they integrate with the memory allocator, and I don't have good memory allocation infrastructure at all yet. So I'm a little bit, I mean, it would call the delete operator, and I think that would panic, but we could try it. And is there a shared pointer? Shared pointer. Bro, what's wrong with your green GS theme? What's wrong with it? We can choose another one if you want. Shared pointer? I'm not seeing shared pointer. I don't really understand why it would include unique pointer and not shared pointer. But okay. Okay, but turns out we do. Yeah, I don't know. Bit set, whatever. Initializer list, you know. Optional. String view. It's like kind of limited, but the last things I think I would check out are variant, maybe tuple. My tuple. Wait, how does this work again? I believe that is how I can construct a tuple. Oh, I'm always forgetting to include these things. Tuple. I guess I did not print anything out. Tuple. Kind of annoying that I need to just print formatting everything, but it's like, oh shit, do we have std get? I sort of forget how you do this actually. And just curious, is there pair? Std pair is in std utility. Okay. Why are you doing this? Is it your project, college assignment, open source for fun? Dude, yeah, Ismail said it perfectly. Kernel hacking for fun. Yeah. It's really, yeah, just for fun, for learning. Yeah. Yeah, so maybe pair is like a slightly easier thing, but this my tuple 42. Okay, so that worked, and so we can just do we can just access the different parts of the tuple this way. And shit, I did it wrong, but we need, I don't know, is it float and char? I really don't know. Percent. How? Wait, man printf float? Oh wait, okay, the printf doesn't support floats. That's, yeah. I mean, specifically C printf does not support floats. That's the only explanation for this, because otherwise that should have worked. But okay. but whatever, in general, like things are quite working. So now the real heavy hitter is variant. It would be pretty cool to use variant. So what is an example of using variant? I'm just going to make a couple structs, A, B, and we'll have int A data. Yeah, maybe it is hard to code. I don't know. Yeah, in general, floats are not really used in the code base. So int C data 1, C data 2. So this is just a basic example. Variant A, B, C. So we make a variant out of this, and then we have an A, B, C. All right, but this is kind of a bad name. ABC type, maybe. Then we have an ABC type called myABC, and then it just sort of initializes into a default state, and then down here, then we can just do something like myABC equals, let's make it an A42. And then we need do we have the methods of like that we should absolutely, why am I flipping back variant? So we do we have visit? Yes. So stood visit my ABC and auto what am I trying to do? I'm just trying to, all right, visit is a little bit annoying. I just want to do, I'll just do a get if maybe. Do we have get if? We do, okay. If auto p equals the get if a and my ABC. What you pass it a pointer. And then this, does it give me type hints? No, I should split up, but then if it worked, I could do something like what do? I do my ABC and it's an A, so it's the A data and I would do A data, and it's like P, it's a pointer to the A struct, call it PA. So this is sort of a test of that. But I mistyped it because there's no, okay. Oh. Oh, check this out. It threw an exception. Wait, no, it didn't link. It failed. Okay. Interesting. And if I want to use variant, I need to provide abort. How do I do that? It's a serious question. How do I do that? Is it... Yeah, like, it's just a C function that I define somewhere, right? So is it just like, I mean, if I infinite loop, is that enough? But it needs to be extern C. Okay, that worked. And our variant code worked. So that is interesting. And this probably needs to go into the CXX runtime.cpp with the rest of this stuff. And yeah, I don't know, I'll put it at the top. And panic abort called. So now let's actually see this being triggered. This will be fun. So this is all working. Our variant is varianting, and now let's trigger the exception by making this a actually, how do we do that? First of all, we would make this like a B, for example. We would make it contain a B. Or actually, no, we could keep it an A, and then we do something like std get B, my ABC. And it's time for a quick break, so feel free to stand up. All right, so we're going to do a regular get and attempt to get a B out of this. And this is an unconditional, like, aborting get. And since it's a type A and we're trying to get a type B, I fully expect this to panic or exception or, oh wow. But maybe I am wait a sec. All right. So that's what I thought. Oh, you don't pass a pointer, do you? You pass a reference. Looks like it. Check out how bad this error message is. Like, like what the hell? Okay, I need to not pass a pointer, I believe. Yeah, check that out. So now we're aborting at runtime. pretty cool. Pretty cool. To really have effective use of variant, you need one helper thing, which is like pretty annoying. And it's that thing with the stood visit that I was talking about. I wonder if they even include it here. In order to really, I guess it's going to be in visit. This is the thing. This is the thing. So you can visit a variant and pass it a generic lambda. And as long as the things you do inside that lambda are valid for all the different types in the variant, that's fine. But then if you want to have specific handling for each of the different types, that's when it gets really annoying, because you need to, it's like by default, it's like really annoying. You need to pass this like functor kind of thing that declares like overloads or whatever. And the ergonomic way to do this is you have this like helper thing called the overloaded whatever. And I don't actually know how to use this, or I don't know how this works, to be honest. But I know that you just need to copy and paste this into your code. And then you can have some nicer, like basically pattern matching. So I'm just going to copy and paste this here. So now check it out. So then I can do this thing that I was trying to do originally. So overloaded, and it's a function, I think. Wait, no, it's not. It's this thing. And then you declare all these lambdas inside of it. So let's just, if I did that wrong. Wait, what did I just do? So this needs, so it's like this. Right, and then we can have a couple of these, and except it's not auto, it's const A, C, right? I feel like I typed that wrong, but I think overloaded, and you have like 3 lambdas and then this. So just curious, does this compile? Expect, no, what the hell? Oh yeah, no. Okay. Also here. Okay, there we go. That looks a bit nicer. So this compiles. And then check it out. So then we can do some stuff like in RA, we can do this. We get the A data, right? In the B, we can say that it's empty. Empty because there's no data in the B. And then in C, we have the 2 datas and we can print them out. Right, and then to I mean, we can use this right now. What we would expect to see is we have the my ABC, and it's currently loaded with an A, and it's going to trigger this line. So let's try that out. But I'd mistype this. It's C, capital C, lower data, and that works. And here we go. Here's our visit, A data 4 to 2. So now to really just kind of bring it home, what we can do is we can make a container of these. So std array of ABC type. Let's make 4 of them my ABCs. And we can initialize them with the std initializer list. So we'll have a it's a 42, we'll have a B with nothing, we'll have a C with like 1 and 100, and then we will have we'll have another A that is like 2000. And we declare this thing, and then what's up digitalized? We are technically still on JOS, but it's increasingly becoming this Frankenstein thing, and slowly the JOS will like get out of there. But yeah, technically we're still in JOS, yes. But we're like going really hard into the C++ support right now. So now what we can do is call it each or something, and I'll use that C++ iteration syntax, which is kind of nice. And we'll loop over all of the elements, and then we will visit each one of them. And then it's going to dispatch based off of whatever the type is and call the appropriate print function. And if this works, this would be a pretty complete example of like really using C++. We have like templates and array and a variant and lambdas and like all this stuff. I'm pretty confident that it'll work. So check that out. A42, B is empty, C data 1, C data 2, and then A data 2000. So that's sick. Yeah, I'm super pleased to see that. Nice. So we did a little bit of a dry run, not dry run, but like a little bit of a, I don't know, kicking the tires a little bit of, and this is just the freestanding CXX headers. So, and we haven't even really gotten to any of these like template I mean, this is kind of a little bit like a minimal library. I mean, one thing we can also kind of do is test out std move. Actually, I sort of want to do that. So what I will do is I will just make a basic type called a movable struct, and it's going to have a pointer. We'll call it pdata. I'm just coding this like straight off the dome right now, so yeah, might not work, but okay. So movable struct, and I don't know, just for completeness, we'll have a copy constructor, movable struct, other, and this is not really the right way to do it, but I'm just going to copy the other pointer directly. And then lastly, we can have a move constructor. And I sort of forget how to write. It's been like a while since I've actually written a move constructor, but basically the most simple version of the move constructor is going to be something like p data equals other.pdata, other.pdata equals null pointer. And we're going to move the ownership and transfer the ownership of the resource from the other struct into ourselves. If I got that right, it's been a kind of a while, but I'm pretty sure that's how this kind of thing works. I think in practice you would use like std swap actually. Curious. Would std swap be more idiomatic here? Yeah, apparently you're supposed to like use std swap or something when you write move constructors. Can you just do it for me? Keep. Okay. But actually, yeah, do we have std swap? I'm not sure. It's defined in these things, which I think we should have. So yeah, and so this is our movable struct, and let's test it out. So we'll have the movable struct A, and we'll construct it x equal some data, and we'll construct it with a pointer to this. Let's say, hey, behind, welcome. So then we have that, and actually what I'm going to do is I'm going to add a print. Moving. Just so we can see it run. And then I'm going to std move A, right? So now we're going to construct a B and have it be move constructed from the A. And after this, we should be able to observe that the AP data should be null pointer, and the BP data should like have something, and it should be the same address as some data. All right, so we should see that some data is equal to B. What's up, Aiden? Yo. And what headers do I need? I am anticipating a build issue because I didn't. For initialization, oh shit, I did not. Okay, so to initialize this, we need to make an int data p data, right? Okay, and that actually just worked. We didn't need to add any explicit includes for swap or move, probably just because all of these other includes already kind of include them. And we technically could go out of our way to add the includes for them, but for such a basic functionality like std moving, I think it's a little bit overkill to do that. So now let's check it out. What happened? Some data is that this EEC thing, and then we're seeing that A data, well, first of all, we see the moving print, which means the move constructor is running. And then we see that A data is null now. It formerly had something. We could even print, we could even do this before the move just to really observe it change. Where are we looking? So AP data, AP data starts out as the EEC. Then the move construction happens. Some data is at EEC. And then after it, A has a null pointer, B has the EEC. And so we've successfully transferred ownership of the pointer, quote unquote ownership of the pointer, into the B struct. And that is the fundamental operation of move semantics. And it's pretty important if you want to use modern C++, which I sort of think I want to do. So yeah, check that out. This is a very C++ heavy stream today, but that's because we're really getting into it. So yeah, this thing, yeah, it's an important concept, especially in modern C++. Like you can't really use smart pointers without move semantics, because unique pointer is a move only type, and so to even use unique pointer, you need to have working stood move, and it seems like our stood move is totally working. This thing should probably go into its own header. What would that be? So when does that work? So then how does that work with R values? That's what confused me. Yeah, totally. Yeah, I mean, it's a somewhat involved topic, but basically the whole idea of an R value is it's something that can be moved from. So it's something, so to kind of to use different words to describe moving to me is sort of like stealing resources from something and taking it for yourself, basically. And an R value is something that is eligible to be stolen from, mostly because it's not going to be used anymore in the future, or it's a temporary variable that doesn't really have a useful future, and so you can steal its resources and be more efficient. And what we're doing, so basically the R value, that's what this double ampersand is. That's what the R value is. And when I say stealing, this is what stealing resources looks like. We are taking the pointer from this other thing and we're assigning it into ourselves, and then we're stashing a null pointer into this other object such that it no longer has a pointer to the data it held at one point. And so we've really kind of like ripped that thing out of it, and now we own the data. And the way you engage in this behavior and the way you trigger move semantics is partially with stood move. And so in this case, A is like an object that exists. And so under normal circumstances, it's not eligible to have its like resources being stolen from it because it might need to use them. And stood move is the way we express to the language and the compiler that we are explicitly marking this thing as being eligible to get stolen from. And this is how we officially say, like, okay, compiler, like, we don't need this thing anymore. Treat it specially and enable move semantics. 20-second break, be right back. Yeah, so I don't know. I don't know if that helps at all. It does take a little bit of time to understand. Um, but that's sort of like what our values are. And stud move is just a way to kind of engage that behavior. Weak pointers are kind of like a whole different topic, and to be honest, let's do that in the future. I would say it's quite a bit more niche. And I use smart pointers a lot at work, and almost never do I use weak pointers. And so it's for like quite particular situations. I would say unique pointer and shared pointer are like the actual just kind of key things to know. And really it's just unique pointer. Like shared pointer is useful, but it's tricky. Like it's a little bit more subtle to know when to use it. So, okay. So I'm pretty satisfied with this. This is all really cool to see that it's working. I'll just make a commit test many CPP features. Yeah, like Rust has all these concepts too. Rust has move semantics, copy. I mean, it has all this same things and more. They're called differently, but the things we're talking about right now are not like so particular to C++. I mean, like the term R value is kind of, and a move constructor is, because Rust doesn't exactly have constructors from what I understand, but conceptually, the idea of like a function that steals resources from another object on construction or copies resources, as like those are kind of general concepts if you're using kind of a more object-oriented way of programming. Okay, so okay, so this thing kind of should go into its own place. Maybe I will just do that now. I'm going to just duplicate this. And what do I call this? It's just going to be like, I'm just going to call this overloaded. And maybe pragma once. I haven't really been using pragma onces, but I think I kind of should. Okay, and then we're going to include overloaded dot HPP. And does this work? I think it does. Cool. Oops. Okay, we're going to amend this in here. So we got our nice helper thing. And let's keep it moving. So I kind of used up most of the time just exploring freestanding CXX headers, but really the main intention was to actually check out some of these other libraries, like ETL, Frig, and BSL. But actually, I think BSL is not really that interesting because I think it sort of just supplies a lot of the things that we already have in freestanding CXX headers. It doesn't actually have that many useful like containers or anything. So like it's a lot of just these like utility things from what I understand. Although it actually does have FMT, which might be kind of nice. So this one is lower priority for me. But let's check out Frig. To be honest, like that's the one that I'm most excited about trying. So let's check this out. Just gonna use master. And so Frig it's the C++ library that is used by the Managarm OS. And it looks kind of nice. Like they have their own variant, I guess. They have a small vector, a string. To use this, I mean, they have their own optional, like to use this, probably a lot of that stuff will need allocator support, which I don't have, and I'm not sure how to do, but I am just kind of curious and kind of want to try using it. So, and hopefully they use a namespace. I think they use namespace FRG around everything, which is nice. Okay, so actually just quick check, because I know that so do they use std? Yes, check it out. So they use std swap, tuple and std move. And so now that we have this stuff working, we are able to use Frig. Yeah, Ismail, I think it is specifically an OS dev designed C++ library, because it's used, like the main user is this operating system, which is apparently really good or something. So I'm inclined to just like use it. Okay, so let's get in here. So we're going to do a similar thing. Touch Frig, no, make dir Frig, cd Frig, git clone depth 1 upstream git and going to just copy the hash, do my weird commit file, and go into upstream and delete the .git. And then now we can try to integrate it into the build. And I don't know, that might be an adventure. I'm also gonna, it's kind of annoying to get these squiggly lines there. I'm not really sure how to fix that, so that'll be a bit of a to-do. Okay. So now we're trying to, I'm going to use the CC runtime cmake list as an although wait, this is a header only library also. This might be super easy. List.text. Let's just copy this one. Copy path of active file. And xfrig. And so this is a header only library, if I am understanding it correctly, which means it's super easy to get working. I just need to pass include here, theoretically. And except one thing is that this thing target link libraries. I don't really know. Wait, what did I do? No, this is wrong. Private. Okay, it's going to depend on the C headers. Pretty sure. That's pretty cool. So need to make sure to remember Yo, what's up, Meg? I don't understand your message, but I see a lot of praying hands, so cheers to that. So now we have this thing kind of bundled in there, and we could even try to use it if we wanted to. So let's do that. I'm gonna have the kernel depend on Frig, and then we're gonna go back to test.c++. I mean, first let's just see if things build. Oh, and interface can only be used with interface keyword. Okay, so I need to go to here, interface. Okay, so that it's working, although we didn't really do anything, but that's cool. And time to go here. So yeah, what should we do? Let's just try to use something from this library. And the way we're going to do that is first we need to choose what would be an like Frig array, maybe. It is a little bit redundant to have like std array and then like Frig array and stuff. But whatever, that's just how it is. Yeah, yo, Plebish. Nice to see you, man. It's been a while. Yeah, cheers. Hope you're doing well. Good morning. So let's try using Frig array. And to do that, I'm going to include frg array.hpp. And let's see what happens. This might blow up or not. Nothing seems to happen, which I guess is maybe a good sign. So now I don't know, let's make a Frig array. Frig array int 8 or something. My Frig array. And my Frig array printf Frig array lm each. I wonder if this will work. No template named array. Oh, whoops, shit. I forgot this thing. Wow, check that out. Frig array, blah, 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 blah. So that was pretty easy. Nice. So now we have, at least we have array working. Yeah, that's simple, huh? Why was it that simple? I mean, it's that simple because I think it's just all about how, like, it's kind of like you said, the library is designed for operating systems development. I mean, lightweight utilities. So it's designed to be very self-contained, basically. And it doesn't have that many dependencies except for the C headers, or actually, and the CXX headers. And since we've already just taken care of that and verified that that's working, it doesn't need much more support than that to work, basically. So that's kind of nice. I don't know, formatting, like, interesting. So it has, theoretically, it has its own format implementation. Yeah, build system looking pretty well rounded. Yeah, thanks. I feel like it's really coming together. Like, it really makes me happy that I can just kind of add these third-party libraries all in this one directory and kind of just make these little CMake files that kind of integrate them into the build. And then it makes me really happy that I can then just add these dependencies from the kernel onto them. And then behind the scenes, the build system is taking care of all the details of, like, adding the right command line arguments to find includes and stuff like this. And so this has been the dream for the absolute longest time. Like, my gosh, like, working with those make files for so long was just so painful. And even in the best makefile setup, you can only get so far with how much you can kind of emulate this behavior of, like, targets with kind of encapsulation and stuff like this, and dependency tracking. So now we're kind of in the promised land for the moment. We'll see what awful build problems happen later. So I would be very interested to try this printing, but somehow I would need to integrate it against my, like, existing console printing or whatever. So but that's like what the sync is for. And so apparently you can implement this sync type, and Frig is going to just, like, use your sync. But I think, not going to really do that right now. But check it. I mean, printf is probably pretty similar. They probably also need some concept of a sync. But for example, that would be really awesome if I could use this printf implementation rather than, like, the random printf that is included in JOS, which apparently doesn't support floats. I'm curious if this supports floats. I would be pretty surprised if it didn't, because this seems super industrial strength print floats. Sync.append. So I wonder, I mean, I don't really know. Maybe it's time to switch to the actual text editor. But it would be kind of cool if we could like learn how to make a Frig sync. So do print chars sync, and then what sync dot append. What is up with? Oh, this is a concept maybe. Formatting.hpp. Yeah, so sync is a concept. So this is like somewhat new C++. But actually, now that I think about it, I think I want to take the opportunity to try bumping up the C++ standard to 23, just because why not? And so far that seemed to work. Okay, but I'm kind of accumulating a bunch of different changes here. So we have, it's time to make a commit, I guess. So we have I don't see the file. I thought I git add commit. Did I do this right? Oh wait, yeah. So wait, what is going on here? Why? I think this was an actual bug. All right, be right back. I think this is, I did not mean to change this away like this, so I'm going to drop and discard that. Hope things still build, run. Good, okay, so we have our upstream, we have this thing, we have the commit, this thing. So I will actually, the commit will only be to just add Frig. Add Frig. Then next commit will be to actually start using it. Use or try Frig. And then this is like kind of random. Use C++23. And that can go, I don't know, all the way at the beginning of the branch maybe. All right. So Frig is looking pretty cool, and we were trying to use this sync thing. And let me see. I've actually never really used concepts before, so this will be a first for me. Struct my sync. Okay. And we just have a type. That stuck using C++98 for my, oh man, that's brutal. That is brutal. And then we have what? Some methods. Append const char. So I think they were trying to make this as easy to integrate as possible. And char C. I'll make it const because why not? And in our case, what do we do? Yo, Ramp Rowdy, thank you. Thank you for the title compliment. So C. there's like other functions. I don't really remember them, so I'm just going to do this. I'm just going to have them call cprintf. And I even wonder if this will work. Any thoughts on that? Append. It's like we're just printing. We're either printing a string pointer or a char. So what? So okay, so that wasn't too bad. So then, let's say we have a sync. What can we do with it? I sort of print format. These don't seem like the functions that are like I would want to use. Like, these seem kind of internal. Print format agent string va struct. I was sort of hoping this would be kind of easy. Printf format. So this function is used in their tests. Wow. Print from test agent format vs. They have their own VA struct concept. Okay, this is like kind of a bit more intense than I would sort of like to get into. But is format so intense? Like, is this like a Linux type? So Linux is not involved here. There's no Linux going on at all. Okay. I'm a little bit confused. I mean, I can see that if maybe I could use these functions, I could pass in my sync. But the question is, like, what is format object? Oh, and maybe the format object. String view, string. Let's just say it's, oh, what? You know what? I think we can do a simple experiment by just trying to print out an integer with this library. Let's give that a shot just for fun. So we're going to Frig formatting, and then so what the entry point is like this. And so we're going to frg format int f QE. I'll do this. Okay, and then we're going to pass it QE, and then the my sync. I don't know. Then I'll add a cprintf. Tried to print from Frig, just so we can see it. I don't know. Let's try it. Ooh, okay, so this did not compile. Redefined. Okay, maybe this is interesting. So VA start and VA end are macros. And Frig defines its own. Wait, is that true? No, it includes std arg. So it tries to make use of the macros. If I just right, that was wrong. Okay, so std arg. How much DSA have you done? None. Literally not done any data structures yet, really. I'm trying to, the goal is to kind of not write my own data structures. So this is our std arg. And this thing is just trying to use it. Don't understand what a sync is. Yeah, so a sync is just basically like Frig doesn't know how to actually get the data like out. Like it also doesn't want to make an opinion about how to like actually print things, like, and so that's like my job as the person that's trying to integrate with Frig. Frig asks you to supply an object that will receive like a byte or receive a string pointer, and then do the actual decision of like how do we actually print this or like output this. And it's pretty simple. It's just, in my case, I think it's just like Frig gives us a char or a string, and then we can then integrate it against our internal implementation, which is cprintf in the case of JOS. Okay, but what? So wait, so we were getting errors about a macro being redefined. What's up, Tom V? We're checking out this library called Frig, which is this C++ library that's meant for operating system development. Oh, interesting. VA arg define VA. And this might be another example of JOS getting in the way, because JOS also includes a VA arg implementation. Yeah, JOS includes its own std arg. So this is a bit unfortunate. And I wonder, yeah, the strikes are adding up against JOS. This is another case where JOS is kind of interfering. Oh, check it out. I wonder if this file is taken from NetBSD. What if I comment these out? Because we technically are providing like there's technically a legitimate std arg.h that exists now, and I wonder if we can just comment these out and everything will fall back to the actual good one. No. Okay, that did not work. Whew. Okay, maybe for the moment I can relax the W error flag, which means we will have a warning maybe. Also, check that out. It's so cool that I can tweak the compiler flags, and then the build system knows to rebuild everything because I did that. That's not something that, I mean, it takes a lot. Like the make files had so much hackery to like make that work, and that's just something that we get with CMake. Okay, so now these things have been converted into warnings, which is okay. And now here's the real problem. No matching function for call to format. And expects an L expects an L value for the second argument. Interesting. So what that just means is that apparently it didn't like auto s equals my sync. It didn't like that I just directly declared it inside calling this function. It wanted me to make an L value. Okay, so now check it out. Redefinition of S, dang. I already have an S, okay, should, sync. Hey Miho, nice to see you. Odd that JAWS provides their own implementation. I thought std arg should be provided by the compiler. Well, the idea with the JAWS setup is relying as little on the toolchain as possible, basically. But also like kind of the headers like this and the compiler are like kind of different things. I mean, I'm not really I don't know how they're actually shipped, but the style of JAWS was to have the compiler and then not really have any other dependencies other than that and provide everything else itself, including all these C headers. And that like continues to be the style that I'm working in actually. And so in my new setup, like I'm using Clang, but I'm providing my own C headers, and I've kind of upgraded my approach. Rather than using these weird like JAWS headers, like who knows where those came from, I'm using the freestanding C headers from the real ones from GCC, or I guess I think they are from GCC. But it's conceptually still the same approach of not really using the compiler doesn't really provide anything but just the compiler, and then we provide everything else. Hey, what's up, Pato? Use Rust, bruh. Dude, that's so true. Yeah, I should do that. I should do that. Okay, so this like worked, and check it out. Check it out. We have a 33. So that worked. We printed from Frig. We got Frig to print our integer, which means our sync is working. And maybe we could even use some of the more advanced formatting functionality. So I wonder how hard that would be, but like, just quickly taking a look. So what is, oh wow, this is taking a, okay, could have sworn that was working earlier. Do the old fashioned way, search for void format, maybe? You know, let's take a quick look at the Frig upstream tests formatting. Tests. You know, I don't really know how to use this library, so these would be some good examples. So this is the thing I'm trying to do. I would love to be able to use this format hello with the braces. That's like that really modern approach for printing things out. Let's try that. That would be so cool if I could do that. And I wonder, what's up, Shroot? Oh, you found the commands. Sick. Yeah, I've been added some commands. I think you're one of the first people to use them. Okay, we're gonna do hello. Let's just keep it super simple. We're not even going to have any arguments, but then how do we pass the arguments? Or wait a sec, the FMT? So it's this FMT thing, but the thing is we need to pass a sync somewhere. And I have no idea where to pass the sync. Or wait a sec. Oh, I see. FMT just I think it like returns a string or something like that. Wait a sec. Let's read this more carefully. Yeah, Michal. So I don't think we have that. Yeah. I mean, let's. So I don't think we have. Is it foot format? It's defined in the format header, and in our CXX headers, we don't have format. This is what we have for. This is all we have for our like standard library CXX C++ headers. So we don't have format. So that's why it's interesting to try using this third-party one. And so I see that it returns auto. Whatever, let's just try this. So I'm just going to try hello, and probably we'll kind of wrap things up soon. So super simple. Wait, Frig, FMT, hello. Okay. And does this compile first of all? No. Yeah, actually, yes. It just has this warnings because of like the JOS stuff, but actually it did compile. And we can get a pointer from that. All right, we'll just keep this in just because it's kind of fun to keep appending. We get a pointer. Got this from Fumet, and it's like a string, I think. Rip cprintf, you will not be forgotten. I mean, we still need cprintf. Like, Frig does like everything, but at the end of the day, cprintf is our tool that we're using to push the bytes out to the serial console to actually see them. So let's test this out. It's going to be the hello with the new line, and that compiles, and maybe it runs. Yes, hello, check that out. That is sick. And it even seems like this automatically appends the new line. I'm gonna kill the palm tree. So now let's, I mean, actually we can just, We can just even do this, actually. One of my questions is like, where does that pointer point to? Like, is Frig internally allocating memory for that pointer for like its string formatting? Because I have no idea how it's doing that, because it would need to implement its own like internal memory allocation in order to do that, I think. So that is a huge question mark from me. But now let's try to do some more cool stuff like this. Hello with the argument world. Because that was in the test, right? Ooh, okay, so now do I have a syntax error? I do. Okay. Do I still have a syntax error? Wait, what the hell? Here. Okay. Check that out. Okay, okay. Where is it? Dang. Hello. Shit. But is there a reason why that didn't work? Okay. That's a little bit disappointing. Did I do something wrong? What if I comment this out? I don't. That would be so weird if that did anything, but no. Hello. What if it's just a number? Okay, I'm a bit disappointed. I was really hoping that would work. Wait a second, something is kind of fishy. Hello. I'm gonna add some random characters just to make sure we are really running what we think we're running. Okay, so it's not working. Something something's not, like the core feature of interpreting those braces is not working. And I have to say that's very disappointing. Like, I do sort of believe that I'm doing this right. Check like parts of the format, check the includes. Interesting. All of this looks pretty like freestanding to me. I wonder. I have a suspicion. So if we can just look at this, we can just see that I think this is the overload that's running. We're passing in this string thing. Maybe not sure. Object. Okay. Yeah. I have to say I'm not sure. Escape format. String view spec. So this is where it really parses. Oh, what? Okay, what's in here? Format object. Oh, wait. I wonder. Okay, I have an idea. This thing takes a format string view, which is probably which probably has conversion from const char star. So never mind. I don't think that's the issue. Tease. It constructs a format impl, which is over here. But what is this thing even? This is a struct. Oh. What's up, Shroot? Hey, Podel. Am I a CS graduate? Yes, kind of. I studied computer engineering. How far are we into the project? We are 82 weeks into the project. That is one way of measuring this. And I would say we're making good progress. We have a solid base foundation for the OS. To be clear, I didn't start 82 weeks ago trying to make this base foundation. I started a couple months ago. Hey, Yosef. Oh, nice. That's great. All right. Well, it would have been really great to template friend void. What format impl? I wonder. Wait a sec. Format object. So here is the overload for the real object. Wait, I'm kind of curious. What is the auto XX? What is the type of this? What do we get back? And here's how I figure that out. Frig detail format impl. Right, so we don't get back a pointer from this thing. We get back this impl struct, which then has this overload where it can be passed to the format object function. And I don't know how it was working here, where we were actually passing that fmt impl object like into cprintf as a string. I really not sure what was happening there, but my theory is that what if we can create this object and then pass it to Frig format here, and then this thing, and then it constructs the default options. Ooh, this is the Hail Mary. So we make the fmt blah blah blah, and then we pass it to format. That is my working theory for this. Okay. Yo, there, yes. Let's go, let's go. We got it. Hello. Hello, blah, 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 43. There we go, check that out. So now we can finally print data. Check, okay, now, like, I mean, this is gonna be pretty cool. Like, let's print a floating point number. Like, we were not able to do that before. Oh shit. Dang. Are you kidding me? Is wow. Okay, that's disappointing. We are in this massive oh, but maybe I need to say this compiler output. Well, yeah, so that is unfortunately one of the massive downsides of C++ is you get the absolute worst compiler output you have ever seen. And I'm a little bit surprised. Okay, you know what? Let's do something a little bit easier. Maybe let's just try. I'll do 4097. Let's just try some integer formatting. Okay, that like was a little bit nicer. Hex 43, hex 1001. There we go. So okay, we're like partially kind of working. And man, that's like I'm so disappointed with that float thing though. What? I mean, actually, over here we had this basic example. What if we make QWE a float? Right? Does this fail? Oh. Yeah. And invalid operands. To binary. What about double? Is it possible? Okay, this. Like, I gotta say, I'm like a little bit disappointed in the Frig project right now with how they can't. I don't know. They have all this code that talks about floats, right? And they are choking. And I wonder if it's because I'm using Clang. Dang. I wonder. So from what I understand, the Manigarm project, the actual Manigarm OS uses GCC. And I don't know where I would find out how to say that. Or how to like, can I search the issues? GCC. Yeah, I slightly possibly am wondering if it's a Clang problem or Clang is erring on something. Because otherwise I would very much expect, like, it's pretty odd that they would just like have like a bug, like a compile error. Why are you not using ChatGPT? Yeah, I mean, I could. I'm trying to use my brain as much as possible and then use AI for problems that like I just really don't care about. I mean, this is like sort of it. This is kind of an interesting problem. I mean, let's just take a look. I mean, I need to wrap it up pretty soon, but this is just kind of too exciting. So the problem is this. Number, like what is number? Number is the template type. I think. What is radix? Radix is an int. It prints internally to a buffer. Where is that buffer? It has a 64-byte buffer that it... And maybe that's just its limitation. It cannot print... Okay, I don't know. A little bit random. What's the error? Invalid operations to binary expression. Okay, but just for fun, I got this error. Binary, yeah, like you can't, apparently you cannot modulo a double, but what if we just converted this to an int? And here I'm actually like modifying, I'm like patching the Frig library right now, but it like what? So that fixed that issue, leaving this other issue, this extremely intense other issue, implicit of undefined template. All right, this might be one of the times where I use AI. I'm going to use Claude Code. Okay, I don't know. Copy in this whole thing. I just copied this massive compiler error. I believe the library should support floating point correctly for floats and doubles. Can you please read copy path, copy relative path, and check this. So what? So we use it and then wait, this is actually interesting. The type traits? I don't know if Frig is involved in this. I don't know. Yeah, this is above my pay level. Do I work as a freelancer? No. Not yet, at least. Should I accept this change? What kind of change is this? 359? Should I accept? So right, it's like kind of weird that they're calling format integer on a float is format float. Format float. Let's just wait a sec. Yeah, what? Format basics. Let's find this thing. Okay, and then format integer, right? Then format float, right? So I mean, this would be the most incredibly embarrassing bug on their end. How could you, like, how could this even work? Okay, let's just accept this. Oh my, what? Did that really fix the problem? No way. Oh my gosh. What? Like, I don't know anything about this library, but I mean, like you all don't need to be an expert in this either, right? Like, without knowing anything else about this library, anyone can see that it's like weird that they would call integer and not float. But why? How could that bug be there? Like, how is that possible that no one noticed that you can't print a float? Yo, this might be my first contribution to Frig right here. Maybe we could do that next stream. Submit a PR to Frig for fixing their dang. All right, so that's interesting. Back to the original experiment that I was trying. So the goal was to print out some I don't know, like some different kinds of numbers, which like Joss was never able to do. And check it out, we can totally do that now. That's lit. Wow. Okay. I'm satisfied. I'm like very satisfied with that. That's cool. So shout out Claude Code for finding the bug. And I mean, just as one last little thing, does this really not work? Like passing this thing. I mean, I guess it still doesn't format doesn't return format doesn't return a string pointer, so like why would that ever work? Yeah, it returns this thing. So the way you use it is you format and then you pass it to format with the sync, and it does whatever it needs to do. Oh, yo, so I would call that a major win. I'm excited. Now, that's like a real concrete win. Joss was never able to print floating point numbers, and I so do not want to write the code to print a floating point number. I cannot stress that enough, and I'm so excited that we have this library to use. And check it out, I don't even need, like, now that we're using C++ and in C++ world, we no longer need to do the print format thing of specifying the type in every single one of these like things. We just put the braces there and the compiler knows what type it is. So yeah, that's cool. Now the question is, like, was my change here really needed? Or was that just a consequence of like the weird other bug? And this is how the code was before I like changed it. And it seems like this is no longer necessary because this thing is like still completely working. So we still have this like kind of unfortunate double, like this error, but this will go away once we get rid of Joss, which might be coming up sooner than we think. Will go away when we get rid of Joss. So that's cool. And so now we have our test, and I'll just get rid of this line. So now we have our fix. It's like our patch frig fix floating and double printing. Genuinely wondering what could have possibly happened there. Okay, so now we have our cool test formatting with frig, and then this was just to stop having the compile error. So I'll just leave that here for the moment. But yeah, like Ismail said it best, it's a nice baseline to work from. And so it's just sort of like making sure you have the right tools available to you before you start a project. Like, imagine trying to build a chair, but you don't even have a hammer or nails or screws or anything like that. Like, the first thing you need to do is like get your basic tools. And programming without tools like printing and, I don't know, like array or whatever is just such an impoverished experience that I think it's worth investing into this infrastructure. So how much of Joss is really useful? That's a great question. I mean, it was useful in the sense that it taught me everything I know about OS programming, but in terms of the actual code I'm going to use going forward, I think I will be referencing it quite a bit. I mean, I think when I actually start writing my own OS, there will be a lot of times where I'll have the Joss code up to reference and potentially even copy paste from. I can imagine doing that for, I don't know, things with virtual memory or context switching or stuff like that. But in terms of actually using the Joss code, I plan to get rid of like almost everything and write the code myself, but taking influence from it conceptually. Yeah. So it looks a lot more modern right now. I mean, how can you how can you look at this and like say that's not, yeah, it's like we are solidly in modern programming territory. We have braces in our format prints. So cool. All right, y'all. Yo, what's up, Scraticus? Cheers, nice to see you in the chat. 100% looks weird. Yeah. All right, y'all. I think that's gonna be it for today. What a good stream. I really had fun today. It was just fun to kind of get all of these libraries working, and it feels like we actually have some like good tools to use now. So yeah, please subscribe to my channel if you like this content. Thank you, Tanmoy. Please join the Discord if you want to hang out. Like, comment, and subscribe, and I'll see you next week for a bit more C++ action, Frig stuff, maybe deleting JOS. So yeah, have a great week, everyone. I'll see you next week. Peace.